Hey everyone, so today we'll be covering the topic of pandas, and this is one of the most important chapters that you have to go through if you are aspiring to be a data scientist or data analyst. Um just because this is the one of the tools or one of the modules similar to the one which we have done NumPy. This is going to help you. The NumPy was for uh, array handling or n-dimensional array handling, but this thing is going to help you with the data analysis part. So Panda can be referred to as panel data or tabular data sometimes. So this is tabular data basically means something that is in rows and columns, similar to Excel sheets or worksheets or Google Sheets. You can also consider any data that is in row and column format. And then at some places you can also see pandas being referred as instead of panel data, it is referred as pandas for data science or Python for data science. So that is the importance of Panda, and we'll be covering one by one. This will be our uh, content that we have to cover. So we'll be going through the introduction, then how to install Panda into our uh, current Python, and then we'll be understanding series, what is data frames. Then we'll understand how to do the indexing parts. Indexing is basically the numbering that you see in the chapters like chapter 1 2. So here in the content section you see indexing is 1 2, then 2.1 2.3. So this is indexing is basically used to give an address. Okay, so like you have an house number, so these rows have a house number. So row number 1 has a house number of 1, and that is a way of telling a user that this is the row number. Okay, in Excel sheets you might have seen columns will named as A B C D E F G, and the rows will be named as 1 2 3. So indexing will be of any particular cell will be row comma column. So it is like A1 referring to the row 1 column A. So something that way we are going to understand indexing and why is it so important. Basically, if we ask about importance, you have already covered that part in NumPy, in arrays, how the indexing helps. And then comes the most important thing is data frame. So data frame will be covered, how to create a data frame, how to load data file like files. It could be a CSV file, that is comma separated values, and sometimes in CSV you can also find instead of comma there are semicolons. So we'll try to handle that as well. But CSV basically refers to the data collection that is having multiple columns separated, values separated by comma. Then what are the different attributes in a data frame? Indexing also again in data frame. Then we'll try to understand how to add and drop operations, basically to how to add new data, how to drop new data, like old data from the data frame. What is difference between series and data frame? All those things will be done. Okay, and there are multiple functions which can be used with like it is within the Panda gives us a feature of various functions that can be used to make your data handling easy. Okay, moving so if you want to know, but the general thing is like it is highly optimized for performance and critical code paths written in C, Python or C language. So it's a combination of C language and the Python. Okay, so to start with the installation part, uh, you have to like any libraries, not just Panda, any library. If you want to add into your Pythons, you have to install it. Okay, and to install any library, you have to use pip install function. And you just it will be best if you go and Google what does this symbol basically means and how does this thing work. So it's in homework for you, so why these minus signs are used. Okay, so you just go and Google it. That will be a homework for you to understand what exactly is happening in the at the backstage when you write these kind of statements or any statement in Python. So that is a deep digging, so that way you will learn something new. So to install this Panda library, I'm using the command pip install -q minus user pandas. Okay, so this is going to install the pandas in our system. And again, once that is installed into Panda, we are going to import it, bring it back into our this particular sheet in which we, or the notebook in which we are working right now. So we'll be writing the command import. So import is that command, okay, to bring pandas into our notebook. So import pandas. So that is the command. As is an alias, because you are not going to write everywhere pandas. Okay, so I'll be writing pd as a shortcut to that. And if I want to write anything that is to be referred as pandas, so instead of that I'll be writing pd. So suppose there is a library and you go inside a library and you want a book, and the genre of that book is let's say romance is very first choice for me, because I have also written book in that section. So library, you want to go to romance section, and in that you want any book. Okay, suppose the book is I'll write my book name as Together Forever. Okay, so this is the book I have written under the genre of romance section. So I'll go to the library and I'll go to the romance section, and then I'll go to the book. And you see, I'm writing this example just to make you understand. Going inside anything is being referred as dot. Okay, so that means us together forever. This particular book is inside the romance section, and the romance section is inside library function. So when I write dot, it basically refers to go inside. Okay, go inside whatever thing is written onto the left side. Okay, so if it is like ref dot right, I will say the right part is going inside the left part. Okay, so this is the like meaning of this dot function. Again, it's a best practice to write comments here. So I have written here comment for panel data analysis. Make this is a way to make your code neat and clean. So next time whosoever is reading this, suppose I am a layman and I do not know exactly what I'm trying to do, so I'll just write a comment so that anybody can understand what this is. So for panel data analysis, I'm importing this particular thing as a panel data analysis, because codes could contain like thousands of lines. So next time if you revise, you do not get confused. Oh, sorry, I forgot. Why did I write this import function? Why did I include np? Okay, so it's better to write a comment for that. So I'm importing numpy in case I have to handle some arrays in this sheet. And then I'm writing cbon. Cbon is basically presentation or visual presentation sort of package or library. We'll not be discussing it as of now. So you can even comment it or remove it, does not matter. And similarly, we also have matplotlib. Okay, so we'll be covering that thing in separate section. So coming back to pandas, we have two things: series and data frame. Remember these two words, series and data frame. Okay, now you go back to the original class of NumPy where we studied about an array. What was an array? Array was similar to a list, but the difference was array had the elements of same data type. So array is a collection of similar data type elements. So let's take an example here. My array name is ARR, and in that ARR I have integer type of values. So let it be 2, 3, 4, 5. So all the values are integer type. Okay, and remember the shape of this is one dimensional. Okay, there is only one line in this. Okay, one cross, the one row and multiple column. So this is one dimensional. I can make a list of veggie. So this will have all the vegetables name, okay, like cabbage, it could be spinach, then we can have brinjal, then we can have xyz, whatever, like lady's finger and all. So what I'm trying to say is these all items or these data values are of same data type. Okay, so that is why we call it as array. But if we say of list, it can have either numbers or it's basically mixed veg. Okay, you can have numbers, you can have dry fruits, you can have vegetables. So there is no restriction. You can keep anything in that list. But for array, we have to restrain ourselves to one single type of data. And this data here is 1D data, that is one dimensional data, only one row and multiple or n columns. So this is one dimensional data. Okay, so this data is in a layman you can say it is a series of data. This is called a series. And once I club multiple series, I'm going to get a multi-dimensional array. A multi-dimensional array is going to be called as, if I want to write it, note it down, I'll be writing into multiple rows and multiple columns. And if you remember in Excel, that is what we do. And in Excel, if we do that, it is basically a table, right? Multi-dimensional. It's a two-dimension thing. So it's a table. So if you club or group multiple series into one single unit, it becomes data frame. It's become table. So if it is more than one row, it is data frame. That's just simple difference. Uh, in series, you have one row, but if it is data frame, it is more than one row. Okay, one row or one column depends. Okay, and in data frame, you have more than one. Okay, so let's take an example here. I'm making a list of countries in that we have India, France, and England. Okay. And I'm going to make another list that is called as capitals. So we have New Delhi, Paris, and London. Okay. So from NumPy, the function, if you remember, to make this list as an array, we use the command array. Okay, and this array function was basically inside numpy. So np.array, this function we are using, and I'm applying that function on capitals. We are applying it and we are converting it into arr. And as soon as we convert it into an array, the elements in this particular list are going to be indexed. When I say indexed, it basically means they are going to be given a row number or a column number. Now if I run this, okay, sorry, I have not run this thing. So this is our list again, and if I run this, my array of capitals is getting converted into an array. Now to make anything um how to say into series, we can use the function dot series. But series is inside which class, like which library? It is inside pandas. So we are writing pd dot series, and make sure that whenever you write series, s is capital. Okay, and Python is a case sensitive language, so that is why you have to write pd dot series. Okay, now suppose if I want to make countries, or okay, let's make pd dot series, and I'm converting the capitals, that is our list. Okay, I'm converting the capitals to a series. Now if I run this, you see I am getting a row number to this. So Delhi is being represented by zeroth row, Paris is being represented by first row, London is being represented by second row. So that is a series, it's a one-dimensional data. Okay. The other syntax is you can write data is equals to capitals, and if you do not write data, as you can see directly, it's working fine. Okay, there is no issue with that. Now I have converted this list into series. Now I'm going to do the same for an array. So ARR is our array. Now if I convert this, you see in either of the cases there is no change in the data. Okay, both are being represented in the same way. Okay, so if you do it directly for the capitals, that is for the list, or if you do directly to an array, this is the way to convert it into a series. If you remember dictionary was a key value pair. So this is my key and the value associated with is this, and key value pairs are separated by column. So we have A associated with 10, B associated with 20, and so on. Okay. To convert again to a dictionary into series, we will be using pg.series and passing the dictionary as an argument. So anything that is having these parentheses are called as functions, and anything that is passed inside, passed I mean to say that is being used inside these functions are called as arguments. Okay, so here the dictionary is being passed as an argument to series, and on running that we will be seeing that this thing is getting converted into a separate series. But the difference here you see is the key is being used as index instead of 0 1 2 3. The key itself is being represented as indexes. So A is representing 10 and that is index itself. Okay, now I'm going to make I have this dictionary sort of thing. But if you see here, countries and capitals, if I want to make this as the index and this thing as its value similar to a dictionary, so India will be representing New Delhi, France will be representing Paris, and England will be representing London. So to do that, we'll be passing two things. So one will be data and other will be index. Now in this case, you have to for beautification, or you have to mention what exactly is being referred. So I'm making countries as index and capitals as my data. Now if I run this, you can see capitals will be onto the right side and it's being indexed by countries. Okay, and this is another example, another dictionary that is being converted. Okay, pd.series. Okay, so now we have certain things. My series, it is one series. Then we have this particular thing, this is not being stored anywhere. uh, no worries, I'll try to do this. So to access the elements, okay, similarly like we did for the list, what we used to do is we used to pass the indexes inside these square brackets. Okay, so I have converted this dictionary into a series, and to access the elements I'm going to pass series 0. Okay, now if I do that, you see I'm getting an error. Why is that? It's because I did not run this section. Okay, now if I run this here, you see I'm getting 10. I'm not giving it a as an value. Okay, that's surprising, right? If a is the index, why I'm getting the value at 0? Because Python is intelligent enough to understand that the 0th position is being referred as a, that is the first element. So instead of that, if I write a, I'm going to get same result. Okay, so what happened here? Why did we do this if it does not like affect the results? So this is a way of beautification, you can call it, that for humans it is much easier if it is this way, that it is easier for them, you can do that way. Or if you prefer doing with zero and that way, it is always okay with that. Means you can apply either of the cases. There's nothing to be worried about. Just a second. Yeah. Now the slicing thing, you know this is called as slicing. Okay. So slicing basically refers when we want from the data or the output from one location to another location. So this basically tells starting position and this up to what position you want. So if I want first three elements, so you know the counting starts from zero. So zero, the first and second element. So it becomes three element. If we want that, so my series colon zero colon, you can, if you leave it blank, it is going to be taken as default, that is zero, and up to third element. So we are getting a is equals to 10, b is equals to 20, and c is equals to 30. But if we specify, it is going to give us from that position to up to. So the last element will be the sixth one, not the seventh one. Okay. So this is my list. Okay. What we did was, uh, in earlier case we converted that dictionary. Okay. Okay, just a second, let me add one more line here. So my underscore series colon a. So if I run this, I'm going to get 10. Okay. So that means from my series, fetch me the value of that particular row which has index as a. Okay. Now I do not want just for a, I want for many more. Like suppose if I want for a, and I also want for b, and I also want for c. So I'll do one thing, I'll make a list out of that, and I will pass that list inside my series. So it is basically telling the Python that okay, now I want of a, of b, and also of c, the value of a, b, and c. So this is a way where you can pass multiple indexes into the series as an index. Okay. Now I can also write it as this way. I want from A to C. Okay. Now if you see, this way is a bit tough when you compare writing it in another way, and that is if I want from 0th to 3rd. So whatever you feel is easy for you, you can do that. Okay. So in this case, I'm writing from 8th to cth index. But if it is numerical, it is much more easier for me. So that is why I keep it numbers. But nonetheless, it's your choice, whatever you want to keep. So I want from A to C, and I run this, and you see, uh, A is being referred as 10, B is being referred as 20, and C is being referred as 30. And that's all. Okay. Now, before moving ahead, I'll tell you this particular class of pandas will be divided into two separate lectures, because it's very long. So I will not make it long in one. I will not be covering in one single lecture. We'll cover it in two. Coming back to data frames. So the difference between series and data frame is series is 1D and data frame is 2D. Okay. Now since it has become 2D, means more flexibility to do any kind of mathematical operations. Okay. And we'll be using Panda in that case to do all those mathematical operations. So we have one list that is fruits. Okay. And to make it as a data frame, we'll be using pd dot data frame, and out of this word data frame, D and F are capital. Okay. So this is going to be the name of my data frame. In this, as an argument, we are going to pass the data. What will be the data that I'm converting it as a data frame is fruits, and fruits basically refers to these columns. Okay, these values, and that These values will be apple, banana, coconut and dates. These as are 4 rows. Okay, and if we do not give here, like this is, let's skip this as of now, and if I run this, you can see what I'm getting is indexes as 0, 1, 2, 3, and it is indexing this at as 0th column. That is a general sense, right? But I do not want 0 in tables. If you remember using Excel, you remember that there were some headers on the top of any column. So if I name it as 0, 1, 2, 3, it's not easy for me to understand or fetch the data. Suppose there are like 70 columns, and you do not know, like you cannot remember every column, like okay, I want 13th column, I want the value from 17th column. It would be much more easier if it is given some aliases or some names, like okay, in column C is basically the salary, and we name it as salary. If any column has age as number, sorry, age as the data, so better to name that column as age. Similarly, naming the column on the basis of given data set in that column is a better practice. So I'll change this 0 as fruits, that will be referring as the name of our column. So I have written column, that is the command. So columns is being referred as fruit, and you see this is being passed as a list item. Okay, the reason being, so if there are more than two lists here, there are more than two, so it will be like suppose there are one more column, I can just put comma and I'll write calories. So column 1 will says about the fruits, and the column B or the second column will have the calories. Okay, so as of now, let's delete that. So if I run that, you can see now the 0 has been renamed as fruit. Okay, moving back to the thing which I was telling, if we have more than one column, so we have Rick 0 O plus. So this is basically name and the age and what type of blood he has. So this is a list inside a list. So if you can remember from the first class, this you can order from the NumPy class, you can see this is a something for 4 rows and 3 columns sort of thing data that you can see, and the shape and size, you can see the rows into columns. So rows we have 4 and columns we have 3. So this is 4 cross 3 data. Okay, 4 rows and 3 columns. So now the data is going to be people, and the name of the columns, so I'll be putting the first name as name, second as age, and third as blood group. Okay, let's remove this and see the difficulty as of now. So I'm converting this as a data frame, so I'll be writing pd dot data frame data is equals to people. Okay, if you have just one single column, you can even remove this. Okay, but it is good practice to write, because that way your code looks neat. Now if I run this, okay, one more thing, df you can find, like in most of the cases, df is a short form of data frame. So whenever you are making a data frame, it's good practice to add df to it, so that whenever you are referring back to it, you just know, okay, this is a data frame. So we are making a data frame called as people, and you see the columns are being named as 0, 1, 2, and this is not good if we have multiple columns. So better to give a name to these columns, and we are naming it as multiple commas, naming it as name, age, and blood group. That's all. Similarly, we can do, if we do not have a list, we directly pass a dictionary. In that case, Python is brilliant in this case. Now it is like analyzing it and understanding, okay, so name is being like name is having values, and those values are Ricky, Marty, Summer, and Beth. And then we have age as a key, and it has this value. Then we have blood group, and that has this particular value. So it is sort of, these are the rows and these are the name of the columns. 1D is basically when you have data in one dimension, that is one single row or one single column. Okay, but 2D means you have data and in row as well as in columns, but there are multiple rows. I'll just give an example here. So my, okay, just let's take this example itself. So I'm just writing this into one single line. Okay, so this is what, this is basically one row or one column. So this is one dimensional data. If I want to make it two dimensional data, what I'm going to do is I'm going to make two rows. Now our data set has two rows. Now we have three rows and three columns, and this goes on. Okay, so what is happening here is our data now have more than one row, more than one column. So difference between 1D and 2D is if there are more than one rows and columns, it is two dimensional. Two dimensional basically refers at to define any element in this space. In this two dimension, we will need two parameters, x and y coordinate. If you remember the diagram which I showed that day, uh, what it was like, if it is one dimensional, it is between x and y. So if you have an axis x and axis y, okay, I'll plot it. So I'll not cover 1D, I'm just telling you 2D. So this is my y axis and this is my x axis. So in the basic maths, what we did was, if there is a point here, to locate this point, we'll draw a perpendicular line at the bottom and a perpendicular line this way, and at whatever place this intersects, it is the location. If on x-axis it is cutting at x1 position and on y-axis it is cutting at y1 position, so this particular point P is going to be defined as x1 comma y1. So to define P, we are going to need two points in the space. Okay, so this is the number of elements that are required to define my point P. So we have 1 and 2. So two elements are required to define P. So this is a 2D data. Now if we see the example of this, or let me, so this is basically a cuboid. Now if we have a point inside this, to define the position of this, we'll require something x-axis, y-axis, and this is z-axis. Now since this is a 3D figure, to define the position of this particular point, we need to have three different elements, that is x, y and z or z. Together, when clubbed together, they are going to give the position of the point P. So now to find the position of P, we need three different elements. So it is 3D data. So D is basically your point is lying in how many dimensions. Each axis is one dimension. So that is the concept of 1D and 2D. But to be very to give, if you want to understand how this is happening, there is one very good example in mechanical engineering, tensor flow diagram. So suppose this is my cube and we are getting some stress at any particular point. So suppose not cube, let me give let's take this is a beam. Okay, uh, iron beam that is hanging with your roof. and you have to hang something here. Okay, suppose some boards. So we are going to get a load here and then here. So how this is going to affect this beam, we have to analyze that thing, right? So to do that, we are going to take a point in this, and now since this is a 3D object, to understand this stress, we have to understand it in three dimension, how this is affecting in x direction, how it is the load is affecting in y direction, and how the load is affecting in z direction. To understand the stress in this condition, we are going to need three different elements, stresses: stress in x, y, and z direction. Okay, sigma 1, sigma 2, or sigma 3, or sigma x, sigma y, and sigma z. So this is a practical, just an idea how 3D works. Okay, so if we have data of stress values, now we'll have that data in 3D, not just 2D. We'll have that data in 3D. Okay, so for this point, sigma 1, sigma 2, sigma 3, for this point, so we'll have the data in 3D. So that will be a tough job to handle. So as of now, we'll not cover that part. So 3D basically means your point will be defined by three different positions. Okay, now we have this dictionary is getting converted. Oh, where is it? This dictionary is getting converted, and if we run this, you see the name, age, and blood group is automatically being picked as the column names. So best practice, if you do not want to give columns, make a dictionary, and it will automatically take the key values as the name of the columns. Okay, now what are the different types of files that we can come across? Like our data can be stored in CSV files, JSON files, Excel sheets, text, videos, and anything. Like it could be photos, any format. Okay, there could be n number of formats. So to do the analysis, we have to get that file into our Python notebook in which we are writing code. Okay, so Panda gives us a freedom to do that, and that is done by pd dot, because we are that functions are inside this. So to read any file, that is read is basically bring it and read it, because only then, once you read it, only then you are going to get the data out of it. Without reading you cannot get. And if I say write, means you are going to add some value or add some data into that sheet. So there are two things, read and write. Okay, so you might have heard of it, read access only and write access. So I want to read first to do the data analysis. So I have read underscore, what type of file I'm going to read. I'm going to read CSV. Okay, as soon as you write read, you see these types are available with Python. We can read clipboard, read CSV, read Excel, Feather, FWF, GBQ, HDF, HTML, JSON, ORC, Parquet, Pickle, SAS, SPSS, SQL, SQL query, SQL table, Stata table, XML. Okay, there are many. Okay, so to read CSV file, we are going to write pd dot read CSV bracket, and now I'm going to pass these things. I'll write file underscore file path underscore or buffer colon, and wherever my file is located, the address of that. It could be some web address, or it could be your local server or local system. Okay, then SEP basically refers to separator. Okay, so by default separators are commas. If you do not give comma, CSV is going to take that. But suppose your file has a different type of separator, your CSV file has semicolon. In that case, you have to mention SEP colon single quotes. Inside that, you have to mention its semicolon. Okay, and then we have delimiter, and delimiter is basically if you want to separate data. Suppose we have dates and you want to separate into three different columns. and it is being separated. DDMM and YY is getting separated with its backslash. So backslash is our delimiter. We are going to use backslash, and then we have a header and many things are there. Okay, so as of now it's pd.read.csv. So pd.read.csv file path or buffer is equals to, and whatever place you are holding that data file. And if it is JSON type, you are going to write pd.read JSON. If it is Excel, pd.read Excel file. Okay, and in this IO is basically the link where your file is kept. And since in Excel there are multiple sheets available, so Python, whenever you write add a new sheet, you will see that it is getting a number like sheet 0, sheet 1, sheet 2. I'm not talking about the renaming thing. If you have renamed it with something, so you mentioned that. Otherwise, you can give the name of the sheet. Okay. If it is not named, you can just give 0. That is default name. Okay. And for CSV, as I said, if there are different type of separators, so like semicolon is being used, so I'll write in double quotes, sorry, single quotes, semicolon. Okay. So now this is the link. Okay, you can check any data set. So I'm using superstore, global superstore CSV file. This is a data set of superstore. Okay, so pd dot read CSV, and then in bracket file path or buffer is equals to the link from where I'm going to pick. So it's available on the web. You can use that data set. There are some predefined data sets like Titanic data set, tips data set. Okay, these are already available with the Python. You can add it by SNS. Cport has that, so you can add it from there directly. So pd.read CSV, from here to end, we have read that file. Now I'm holding that file into my brain. What do? I am going to put that data, whatever I'm holding into my brain, into a variable called as data. Okay, I'm putting that data into Python and I'll rename it as data. Now data dot to CSV. So this is to save. Okay, now if you want to save that file to back to on your system, you can use dot to CSV, to underscore CSV, and whatever the name with which you want to save that data, you can do that. Okay, so as of now I'll just comment it because I do not want to save it, and then I can check my data. Okay, and if I run it, you see this is what my data looks like. So it is row ID, order date, ship mode, then we have customer ID, customer name, segment, postal code, city, dot dot means there are few more columns inside between these two. Then we have ending with product ID, category, subcategory, product name, sales, quantity, discount, profit, shipping cost, and order priority. To understand or to do the data analysis, you must first understand your data. So from this, what I can see is this is a data of a superstore that has certain number of columns and the values inside that. So this is being referred as row ID, and these are the indexes, that is 0 1 2 3 4 dot dot dot. Then we have some order ID related to certain customers who are having certain customer ID, and these products are being shipped into different class, first class, second class, or any other class. Then we have date on which this particular order was done and when it was shipped. And then we have more information like what is the postal code, what is the city code, name of the city. Okay, what is the product. Okay, from we can recognize the product from product ID. Okay, if it is if we want to categorize under what category we are going to put, so it could be technology, okay, furniture, electronics, or anything, something like that. So this is going through your data before moving further ahead. Understanding your data is one of the important job for any data scientist, because if you do not familiarize yourself with the data set, you might end up understanding it in wrong way, and the inference that you are getting from that data could lead could be biased or could be wrong. Okay, so it's better to understand what data. Now at the bottom you see 1000 rows and 24 columns we have got. Okay, so the shape and size of this particular data set is 1000 cross
So,
24.
Bridge, I'm sorry.
Yeah.
I think you stopped sharing, I guess.
Okay. Oh, sorry. Yeah.
It's frozen in the. Okay, perfect. Thank you.
Sorry. Yeah, so to do the CSV file, pd.read CSV, pd.json, pd.read exl, pd. What are the different file types? You can just check it. And let me show you again here. If I write here pd.read underscore, and you will get all the list. What are the different types? I'm not getting right now, but you'll get it. Yeah, see, CSV, clipboard, Excel. So these are the different files that types of files that you can read or the Python has access for. So now we are reading certain files that is in CSV format, and this is located at this particular address. I have taken it from Google. You can check it, and then I'm storing it back into data. So now what I'm doing is I am understanding my data set here. Okay, so I just scroll down and we see we have 1000 rows and 24 columns here. Okay, so now I have made a data frame out of that. So if I want to see this rows and column, I'm going to use the function shape. So data dot shape is going to give us what is the shape of our data. Shape basically means how many rows and how many columns. So you can see I have 1000 rows and 24 columns. Okay, and now if I run, I want to see the type of data, I'll write d types, and then it is going to give me what is the data type of each column. So row ID is integer 64, that is 64 bits. Then order ID is object. Then we have float, postal code, then sales at float. And you see this is order date, but that is in object format. So definitely these things to be kept in mind. Okay, this is a date format, and the type of data which we have is object type, so we have to convert these into date type so that we can perform our analysis in a better way, in a right way. So okay, now we have function one. These are the one of the important functions now I'll be covering. Info. So we have seen two things. Dot shape is going to give us the rows and columns count, and dot d type is going to give us what are the data types of our columns. Now this is a function. Info is going to give us a brief information about our table. Now if I run this, you can see it is also covering the d type. Okay, so instead of remembering d type, that function, we can use dot info, and it is going to give us the complete idea of our table. So it says that our range index is having 1000 entries, and that indexes is starting from 0 to 999. And data columns, we have total 24 columns, and the column numbers or the indexes are these. Name of the column is this. Non null means these are the counts here. So the row ID has 1000 non null data, means it is not empty, and all the cells have 1000. Like count of non null, how many cells are not null. So you go down and you see that postal code is having only 194 not null values. All the other cells are empty. Okay. If you go back to our data, you see we have NaN. So that is, it is empty. So out of all 1000 rows, we are just having 194 non-empty cells. Okay. And that this is giving us a type of data. So total counts, if we want to see, float we have 5, integer we have 2, and objects we have 17, and the memory that is being used is 187.6 approximate KB. So this is a complete brief of your tables. Now we have data dot count. Okay, let's see what does this give. So this is going to give us only the not null, this particular column which we got not null count. So we can also get it from dot count. So it is going to count it. Okay, so postal code has 194. If you want to get the index, dot index, so starting is 0 and stopping is at 1000, and if you go back to info, you see that is being referred here, the second line. So you can, instead of learning this as single commands, you can sometimes just do dot info to get complete idea. Similarly, dot columns is going to give us the names of all the columns available in our table. So I use most frequently this because sometimes I forget what are the different columns. So in the between code, I can just simply go back and run this command to see, okay, these are the names of the column. Because sometimes if I want to fetch the data of sales and I have written small letter like small s ales, so it could give us error. So it's better to check the name of column. So I just run data dot columns and I get the exact name and I copy it, and that way you can use it. Okay, now suppose in this case, what was our indexing? Indexing was done by 0 1 2, that is general indexing. What if instead of that index I want to make my own index, like if you remember the dictionary one? Okay, in that we have a, b and c. So in this case we have a command called as set index. So this is going to change the index to whatever index you want. So I want to make the row id column, that is first column, as the key, okay, or as the index. So keys is equals to row id, and this is being passed inside set index, and this is being applied on my data. So data dot set index keys is equals to row id, and whatever, I'm not going to change it to original, and I'm going to store that thing into another data set called as data2, and then we have the function dot head. So head is going to give us top 5 rows. Okay, if you do not write any number here, so it is if you write n numbers, means top n rows you are getting. If you do not write anything, you are getting 5 rows only. So show me top 5 rows here. So this is top 5 rows, and you see earlier we had 0 1 2 3, but now we just have 4 0 0 9 8, this as an index. Okay, you see it is written on the downside, and in the previous case you see row id and order id are in the same level. Okay, and indexing was done on 0 1 2 3. So now we have changed the index from 0 1 2 3 and all those things to row id. This little button here you see is available only in collab notebook. What it is going to do, it is going to convert it into smart table. You see this is smart table, and you can filter it out like how many rows you want to. Now accessing that data of any column, adding new columns or new rows, and dropping new rows or new columns. So like you remember in the previous case in the series, uh, if you pass the index like 0 position index, so it is going to give us 0th row. Similarly, if I write here data city, and city is one of the column names, so it is going to give the data of from that particular table, all the data available in city column. So we have 0 1 2 3 dot 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 up to 9, and we have these are the cities. Okay, so the syntax goes like my data frame, and then in single quote the column. It could be one column or it could be multiple columns, same as we did with the list one. Okay, in series we wrote multiple a comma b comma c and passed it as a list. So we are going to pass this as list because we are having more than one column. So now I want customer ID and city from data. So this is the way to write that. Now dot city. So this is going to give us the number of columns, right? This is going to give us the number of columns. Now to count this, I'm applying dot shape function on that. Okay, so it is going to apply. Okay, let's break this and do one by one. Data, and if I want the city data here, and let's run this. So it is giving us this data. Now if I write shape, so it will give us what? It will give us the one cross how many columns are there. Now if I want to find how many cities are there, I know this is two values here, 1000 comma something. So I actually want 0th position value. We know we are seeing two more than one value, but I want 0th position value. So this is going to give us 1000. So if we want to count how many columns are there in how many rows are there in city, I'm going to write this way. Now we are going to add one new column, and that column is called as loyalty points. If the customer is shopping multiple times, we are going to give some points to that. So I'm making a list, okay, empty list called as loyalty point, and a random number I'm giving to that. Okay, for I in np.random.rand. If you remember numpy, we did this function random.rand, so it is going to generate random data. But how many random data are we are going to generate? So we are going to generate total number of 1000 data. So that is why I counted how many columns are there, sorry, rows are there. So we have 1000 rows here. Okay, otherwise you could have just done here shape, because instead of counting any specific column, you can do it like this way also. So data dot shape and take the column out of it. So I'm sorry, rows out of it. So I'm taking that way. Or if I knew 1000 rows are there, so I could have simply written 1000, but I'm making it dynamic. Okay, instead of 1000, let it count how many rows are there. It will automatically count that, and then it is going to pick some random value. That random value is being referred as I, and I'm multiplying that random value with 10 because the random function is going to give us the random values between 0 and 1, but I want it in one digit. Okay, like 2, 3, 4, something like that. So I'm multiplying it in 10, so it could be like 2.1, 3.5, something like that. And then I'm using dot append function. So what it is doing is whatever 1000 values I'm calculating as a loyalty point, that is going to be added into the list. So name of the list dot append and this function. Now I'm adding a column. The name of the column is loyalty points. So data, and then in brackets I'm writing the name of my column here, and this column is having the values is this list. Okay, now if I run this, you can see at the end we have loyalty points. So these are some random values here. If I run it again, first is 7.427. Okay, you see the loyalty point has changed 4.549083. Okay, so it is changing because we are using random values, right? So even if you want to fix it, you run it once and store it, and then you can comment this, so it is going to be fixed. Now suppose if I've selected this and I have commented this, now if I run it again and again, my loyalty points are sorry, because I should have done it in the next block, not here. So if I cut this and paste in another block, then it is going to be okay. No worries, you can do it. So the idea here, what I wanted to say is that loyalty point is a random value it is taking, and to add any column, so syntax goes like this: my data frame bracket name of my new column and the value that it is going to store. Simple. So if it is one row, it is value, otherwise it's values. It could be a list. And you see I have given 2 inside head section, so it is giving me just 2 rows here. Now I'm going to add another column based on the previous 2 columns that are already there. So this was if I want to add completely new column, but now I'm going to add another column called as offer price, which is being calculated on the basis of columns which are having the data into the table itself. So we have discount here and we have loyalty points. So I want, if the loyalty point, the new discount or the offer that I want to give to my customer will be discount into, these are the extra discounts, into the loyalty points. So if you have 5 loyalty points, you will be given 5 times extra discount. Okay, that's a huge discount. So I want to add the column offer price. So I'll write data and the name of my column is offer price. And this is going to store values from data.discount, sorry, data discount column into data loyalty columns. Okay, so whatever the values are there in discount and loyalty points, it is going to get multiplied. So 0th row data will be taken from discount and 0th row data from the loyalty points, and that will be multiplied and that will be stored in 0th row of offer price. Okay, so the indexing is maintained in that case when the multiplication is being done. So we have another function called as tail here. So similar to like head, tail is going to give us the data from the bottom 2 rows we are going to get. You see we are getting 999 and 998. Okay, so this is suppose we want to remove any column and we want to club it into one single column, we can do that. Okay, then deleting rows and columns. So first I'll copy. To copy that, we will use the function dot copy, and the name of new data frame is data underscore copy. So I'm going to copy that. So now my original data is being copied because you have to keep your original data safe. Okay, now I want to remove something. Okay, remove, if I want to remove rows, so I'll put sorry, column, I'll put axis is equals to 1. If I want to remove any row, I'll use axis is equals to 0. Okay, now in place is equals to true. So this is basically, we write true when we do not want our original data to get affected. Okay, so we write in place is equals to true. Otherwise, if we want that change to be permanent, we will write in place is equals to false. Now these are like arguments, like labels is equals to row id. I'm going to drop this particular column. So the function to delete or remove any column is dot drop, drop function, and out of that you name the column which you want to delete and the axis, because it is 1, it is column, for column it is 1. Don't worry, don't if it is 0 or 1, you will just write axis is equals to and it will give you suggestion, and you can by that way you can know what it is. So I have removed row id and you see there is no row id here. After that indexing, we are directly having order id. So like we did head and tail, there is another command called as sample, and it is going to give us some random rows. Okay, some random rows. So this is done. Head is going to give us the first. Okay, now if I drop instead of naming the rows, column names, we can also write the indexes. Okay, and I'm writing in place is equals to false. By that way, we will be able to see whether it is affecting our original table or not. You see, I removed zeroth row, label is equals to 0 and access is equals to 0. So means I'm removing the zeroth row. Zeroth row is being removed. Don't confuse with this 0. This is basically referring to rows. If it is 1, it is going to drop. Okay, let's do 1. It is going to drop what? Let's see. It is giving error here because its name is order ID. Now if I do this, you see order ID is deleted and also the rows have been deleted here. So this is one way. Now I'm again using set index since I have deleted that order ID. Now I'm making the customer ID as new index, and that is being changed in the original also because I have put in place is equals to false, and you see the customer ID becomes the indexes here. So this command we have already done, so no worries. Okay, and then we again to drop any column or rows we are going to use drop. Okay, now what we are going to do is we are going to remove any specific customer ID. So we mentioned that customer ID name here because here in for rows we have to put the index here. Okay, so index value is this, that is AB10, this 100151402. If I want to remove that, I'll run it and you see that is gone. Okay, this is second one, JR is second one. If you want to see, you see JR is second one. The first one is removed. So we have learned how to remove a row, how to remove a column, how to add a column, how to add multiple columns, how to add column on the basis of some calculation on the previous already available columns. So all those things are done now. So this is a very famous data set called as Titanic data set. Okay, so this has uh, the details of the passengers who were traveling, unfortunate passengers. So we have some passenger ID, then we have survived or not. If it is 0, they died. If it is 1, they have survived. P class is basically in which class they were traveling. Then we have name, then we have sex, and then age. Sib SP is basically siblings. P arch, then we have ticket, fare, cabin, and embarked. Okay, so this is a typical data set here. While loading itself, we can write what will be the index. So we can write at index underscore col is equals to passenger ID. In this case, as soon as the data gets loaded, the passenger ID column is getting converted as index. Okay, and now we will be doing two things. One is iLock and then lock. Okay, lock is okay, let's do it one by one. iLock, we have purely integer location based on indexing for selection of by position, so don't worry about that. So accessing rows from 0th to 4th index. If I want 0 to 4th and column from 1st to 3rd, so let's not include the column as of now. Let's just see if I want 0th to 4th rows itself. So 1 2 3 4, this is my passenger ID. I'm getting that data. Okay, but if I want column also, I'll write rows from 0 to 4th and 1 2 3. Okay, I'm indexing the location. iLock is basically indexing the location. So 0 to 4 rows and first 3 columns. So we have index, p class, and name. Similarly, if I want for like all the rows, so we just write colon, no start, no end, comma, then columns which we want. So this is going to give us all the rows and 0 to 5 column. Okay, for all the columns and specific number of rows, we write 0 to 4, and the name of the columns is left blank here. So this way we can write that. Now we have another function dot lock. So what is difference between that, we'll understand soon. So you see here we know the like indexes of our rows, but for columns in earlier case ilock was, I is basically for integer location, and lock is basically if the name of the columns are there, you have to give those names itself to tell that I want the data from these all columns. But the feature that is available with ilock is that if even if you do not know the names of the columns, you can just pass the numbers. Okay, I want third column, fourth column. That's much easier. Okay, so if you do not know what is the name of column, go for ilock. But if you know the name of the columns, you can just simply put uh, lock. So I know column is name is name. So, and I want from third to fifth index. And remember, this is not the position. This is basically the index. Okay, this is index. Okay, let's understand here. If I write here, okay, let me copy this. If I paste this, and I want 0th row and all the columns here. So you see, I'm not fetching the data. Okay. In this case, I'm not fetching the data on the basis of passenger ID. This is my index. Okay. But I'm fetching it on the basis of rows. So this is 0th row count. Okay. But here in ilock case, if I write 3 instead of 1, if I write 2, 2, so technically I'm telling I need row number 1, and if I run this, I should be getting name. Okay, this is name and this is brand. Here you see it is 1, but what I'm telling here is I want first row. But what I'm getting, this is not the first row, this is 0th row. If we go for indexing, the basic normal indexing, this is 0th row. But in the lock case, it is taking the name of the index. This 1 to do not confuse this as the name. Okay, this is basically the index. Here passenger ID is 1 2 3 4, that's why it is a bit confusing. But if you, okay, let me take the example of our previous data set here. Okay, and this is my data 2. If it is data 2 dot lock, and I want from here to this. So what I'm doing is I'm mentioning the index itself, and I want order ID, and I'm mentioning the column name itself. What's happening? Oh, sorry. Okay. Now if I run this, you see the data is being picked on the basis of this customer ID, and customer ID is our index. Okay, this is not our general indexing like zero throw. So once you use lock, you cannot use integers. You have to specify which particular index and which particular column you are referring to. This is much more tough when because you have to be very clear about the indexes names and the name of the columns, whereas ilock is having advantage that you do not have to remember the name. You can just write the numbers and it will give you that particular row or that particular column. So I think I'll end the class at this position itself. We are left with some more things and we'll be covering in the next class. So this is today. We are covering the last topic as lock, and in the next class we'll cover more. Thank you so much.